let's go back to the program. So this is our decision tree. Again, the default values, and we have seen the scores that we get for this decision tree. So we get around a mean accuracy of 77% and a standard deviation of around 4.3%. Now let's look at this decision tree. This is a fine-tuned decision tree. These parameters are selected, so these are values different from the default values. And so an obvious question that you may ask is, how do you get these numbers, right? How do you make these choices? And one answer to that is, so it can be a smart guess, right? But there's another method that I'll show you in a few minutes that you can use to get the best values of these parameters. But some of these parameters are, for example, max features, right? You are in your data set, right? You have 7 features, right? So your numbers should be close to that. So one way is you can use smart guessing and head and trial to see what is the best combination. But that can be tedious, right? But it's always a good practice to do that. And the way I got the best values of a lot of these parameters was to first, do smart guessing with a combination of some head and trial. But it's always good to monkey around with these parameters and see what combinations would change. So I want you to go ahead and change, for example, max depth to 3 and change this to 7. But so again, you have you have a data set with 7 features, right? So your max feature should be around that, and there are only 2 possible values for the criterion. Random state is just for a seed for the random number generator that the decision tree uses. So if you do not select this, you won't get the same result. So this is just for reproducibility. So now with these set of parameters, if you again do the training part, predictions, let's run this. And so now let's look at our scores. Right. And you can see that there's a significant improvement in our scores. So we went from 77% to 81%, with the standard deviation not improving significantly. But so let's submit this to Kaggle. So you can go ahead and submit, and you'll see that you get an improved score, a significant improvement on Kaggle. So we were getting around 64% accuracy. Now we'll get around 77% accuracy. So go ahead and submit this file, run the program, submit this file to Kaggle, and check what your accuracy is. So it should be around this value. And now this is a significant improvement in our result. Right. And so we have a decision tree. We have fine-tuned the decision tree. It's a better decision tree than before. And we have definitely addressed the overfitting that we had before in the previous decision tree. And so again, coming back to that question on how to get the best combination, and a good way to do that, and it's the way to do this is to do a grid search using the grid search CV function in the scikit-learn library. So you can again import that, and so you have to choose a range for the parameters that you want to scan. So you can scan on over any range. Obviously, it's going to take more time if you choose a bigger range for the parameters. But again, so as we said, that we have 7 features. So for the max features, search around 5, 6, 7, because that makes sense. And for the max depth, it's your tree is not going to be that deep, so choose parameters around this range, 2 to 5 or 2 to 6. Try changing this if you prefer. And so with this combination of parameters, run this. I've already ran this. And you'll see that you get a best. So this is your best set of parameters in the CLF variable. So you can see that criterion is Genie, max depth is 4, max features is 6, and 3 and 2. And this is what we had over here. And so this is one of the best ways to get the most precise set of features for your decision tree. Okay, so in the next video, let's discuss another method to evaluate your model, which is using the train and split method.